Now let's look at an example resolving forces. Now this is the exact same example we've done previously using a triangulation of forces, because there are only 3. So it's just going to show you how to do it. So the question's the same. First thing I'm going to do is I'm going to write the 3 vectors in component form. So let's start with T1. T1, if we draw the triangle here, so its x component is negative, or its I component is negative, its j component is positive. This angle is 30 degrees because of alternate angles. You can see that there. So vector T1 is going to be equal to negative T1 cos of 30 plus T1 sine of 30 using exact, oh, and I forgot my I and j. So I plus T1 sine of 30j using our exact values. T1 is going to be equal to cos of 30 is the square root of 3 over 2. So negative root 3 over 2 T1 I. Sine of 30 is a half plus a half T1j. Our T2, draw the triangle. This is 60. Our I is positive, our j is positive. So T2 is going to be equal to T2 cos of 60i plus T2 sine of 60j. Their exact values. T2 is going to be cos of 60 is a half, so a half T2i. Sine of 60 is square root of 3 over 2 plus the square root of 3 over 2 T2j. And then we have our weight. W doesn't have an x component, it's going straight down, and it's going down, so it's going to be negative 8j. Okay, I think it helps to write those things out. So now you can resolve. So resolve in the x direction or the I direction. So that means our I components have to add to 0. We have no I component for weight. So negative root 3 over 2 T1 plus a half T2 has to equal 0. I can rewrite that as a half T2 has to equal root 3 over 2 T1 times both sides by 2. T2 has to equal the square root of 3 T1. Now that's going to be equation 1. Resolve in the j direction. So now our j components have to add to 0. So we have a half T1 plus the square root of 3 over 2 T2 minus 8 has to equal 0. I'm just going to leave that like that. Label it equation 2. I'm going to sub 1 into 2. So that means I have a half T1 plus the square root of 3 over 2 times by the square root of 3 T1. So I've just replaced T2 with the square root of 3 T1. Minus 8 has to equal 0. Neaten that up. A half T1 square root of 3 times square root of 3 is 3. So plus 3 over 2 t1 minus 8 equals 0. So I'm just going to take that 8 over. So that's going to equal 8. 3 over 2 plus a half is 2. So 2t1 is 8. So t1 has to be 4. Sub that back into 1. So I get t2 is the square root of 3t1. So square root of 3 times 4, which is 4 root 3. So I'm done. So much easier doing triangulation of vectors and not resolving in components. Personally, write a therefore statement. So there's the therefore statement.